Hello, everyone, and welcome to this Getting Started with KX Dashboards live stream. My name is Megan. I'm a developer advocate here at KX, and today I'm being joined by Jemima Morrish. So, Jemima, do you want to introduce yourself a wee bit?
Yes, hello everyone. My name is Jemima Morrish and I am a junior KDB developer at SRC UK.
Yeah, and Jemima will also be speaking at our KX meetup in London on the 25th of this month. So, everyone can register for that now. Registration is through our website at kx.com. And if you can't make the meetup in London, we also have a meetup in New York on the 2nd of April. So you can register for them now. And to keep up to date with all KX meetups in the future, you can join our community Slack channel at kx.com/Slack. But today we're going to discuss a bit about what KX dashboards are, and we'll talk a bit about how you can get started for free, and then we'll jump into how you can create both streaming and dynamic dashboards. So first we'll look at what KX dashboards are. So KX Dashboards is an interactive data visualization tool that enables non-technical and powerful users to query, transform, share, and present live data insights. Some of its key features include an easy-to-use drag-and-drop user interface, an extensive library with over 160 visualization components. It supports high-frequency streaming with a direct integration with KDB+, and it's open and extensible, allowing new components to be added with HTML, CSS, and JavaScript. So here's a quick look inside the KX Dashboards component library. It's broken into 5 different categories: tabulate, visualize, layout, query, and application. These categories allow users to find components quickly, which enable the creation process of dashboards to be more efficient. So how would a new user get started with dashboards? First, you navigate to the code.kx.com/dashboards website, which is the official documentation website for KX dashboards. Click the download and install link, which will then bring you to our Getting Started guide. From here, click the download button, which will then bring you to our end user license agreement. Take a read through this agreement, fill in your details, and hit the I accept button. Shortly after, you'll receive an email with a downloadable link to your very own instance of KX dashboards. It's important to note that you must have KDB Plus installed in order for dashboards to run. But that's it for the setup. Now we'll switch over to talk a bit about streaming within KX dashboards. So I'll get this full screen. So streaming is supported in KDB through KDB Tick, which implements a minimal publish-subscribe pattern. To enable streaming within KX dashboards, start a queue process on an assigned port. Then in KX dashboards, create a data connection to the streaming process on the specified port. Once this is created, you will then be able to visualize this real-time data through components such as data grids and charts. So, for example, to improve the appearance of data grids such as these two, we can apply highlight rules. An example of this is when a new value comes in, it is highlighted in green if it has increased from the previous value, or it is highlighted in red if it has decreased from the previous value. We can also use highlight rules to visualize values by filling a cell with a color based on the size of the value. Another way to customize components is through templates. For example, in this data grid, a template is used to insert an image of a flag based on the symbol. Other components can be linked to data grids, such as financial charts, which is what you're seeing here. These are a great way to display real-time financial data, as you can choose to add indicators such as weighted moving average directly to your chart without the need for additional code. And I will preview that. So you can add different indicators. You can add Bollinger Bands, or you can add weighted moving average. without the additional adding any extra code. To view the open, high, low, and close prices for a selected period, we can tick the Show Info box. And now you can see the price at any selected time period. So that's a quick run through of streaming within KX dashboards. Now we're going to demonstrate how to build a dynamic dashboard that links components, allowing them to interact with each other. First, we'll start by dragging a FlexCon panel onto the canvas. FlexCon panels are used to configure two components, one to be placed in a panel between a minimum and a maximum size, and a second to fill the remaining area. These are ideal for using menu options along the side of a dashboard or using filtering options along the top of a dashboard. So for this example, we're going to change the minimum size to 50 pixels. In the top panel of the Flex panel, we're going to add a layout panel. Layout panels are used to nest components within a dashboard. These can be added to any other panel component, or they can be added directly to the dashboard itself. Within this, we're going to add a breadcrumbs component. And a breadcrumbs component is a screen control used for pivot or OLAP navigation. We'll configure this breadcrumbs component once we set up our pivot grid. For the remaining space of the Flex panel, we're going to add a second layout panel. To accommodate the multiple components we're going to add in here. So in the top left-hand corner, we're going to add a pivot grid. Pivot groups allow users to analyze large data sets by pivoting, grouping, filtering, and aggregating data in a tabular format. So here we have our pre-configured data source called quote statistics. For this, we want it to show the quote count, the quote spread, and the quote size by symbol, hour, and source. So the first thing we want to do in this pivot query is enable the pivot query box. So make sure that's ticked. Then that will launch our pivot query window. So here we want to include our breakdown columns. So as mentioned previously, our breakdown columns are symbol, hour, and source. You can do that manually by adding them here, but for this example, we're going to create a view state to do this. So here we have our view state called breakdown, which is of type list, and here we have our 3 breakdown columns. Next, we've added our aggregates. So we want the sum of quote count, the average of quote spread, and the average of quote size. So we're going to execute this. Next, we're going to add an empty view state of type symbol called pivot node. Now, this view state is going to be used. This is what's going to be used to link our components all together. So we can keep that empty of type symbol. So now that we've created both these view states, we can now configure our breadcrumbs component. For the path, we're going to use our pivot node. And for our visible breadcrumbs, we're going to use our breakdown columns.
So now we want to add a tab control component. So Megan, if you could please drag and drop a tab control widget.
Yep.
So why a tab control? So the tab control component allows users to switch between different data views effortlessly. It helps in keeping dashboards uncluttered while enabling seamless navigation between different data sets, charts, and sections. So in the basics section on to the right, we want to name this component. Choose a name that reflects the function of the tab, such as Market Data View or Trading Insights, so that anyone reviewing the dashboard can quickly understand its purpose. So now the first tab. 2 tabs are added by default, which is very helpful, and we will need 2 tabs. You can just add another tab by clicking the plus tab button, but we don't need to do that. So what is a tab? A tab in the tab control component acts as a separate view or section where different content can be displayed. Tabs are useful for grouping related data while keeping the interface intuitive and easy to navigate. So Megan will name this first tab quote count, since it will display market quote information. Choosing clear descriptive tab names is essential for assuring users to know what to expect when switching between dashboards and, of course, tabs. So now we can just do the exact same for tab 2. And instead, this will be called trade volume. So now those are the 2 tabs. And we will now get on to what we want displayed in these tabs. And that is a chart GL. So Megan, please, can you drag and drop a chart GL widget? So why chart GL? Chart GL uses WebGL to access the graphics hardware on the local computer, accelerating the rendering process by a factor of many thousand. And display millions of data points in milliseconds using advanced rendering techniques. It also allows multiple large data sources to be plotted on the same chart with high speed and performance. So just like before, in the basics section, we are going to name it. And we can name it something like quote data visualization. Nice. Okay, so now we are going to focus on the first layer, layer 1. So what is a data layer? So a data layer in ChartGL is essentially a collection of data plotted on the chart. So adding layers allows you to compare different data sets visually on the same chart. So we're going to select a data source. We're going to obviously execute and apply this data source. So now, as we can see, that's what it looks like on the chart. And now we just need to configure it to how we want. So this data layer will be named quote count, as that's what we want to display. It's very important to assign clear names to your layers so anyone viewing the chart can understand the data immediately. So next, in our x-axis data, we want to keep that as minute. And why is this? By choosing minute, I'm focusing on showing how the data evolves over time rather than a long-term scale. For x-axis and y-axis, we are keeping that as x-axis 1 and y-axis 1. This is just because we want that. When we do go by adding another data layer, we will be adding another y-axis where we will choose y-axis 2, but we'll get to that in a moment. So now for y-axis data, this is what we want to show. So we want this to obviously be quote count. And now we want the chart to be bar instead of bubble. And now that's exactly how I want it to look. So now let's go and add another layer. So Megan, please, can you add another layer? And this is going to use the exact same data source, but we want different y-axis data and we want quote spread. So that means we need to rename the layer to quote spread instead of quote count. And unlike the bar chart for layer 1 we used for the quote count, we want this to be a line chart. And why a line chart? So a line chart is ideal for showing trends over time, especially with continuous data. The quote spread fluctuates regularly, and a line chart will make those trends much easier to track. So now we need to configure the axis. So I want to add another y-axis to this. So if you scroll down to the y-axis, perfect. And just add another y-axis. Yes, and change this to right, as obviously we don't want it on the same side. So since quote count and quote spread can have very different ranges, it's essential to separate them onto 2 y-axes. This prevents one data set from overshadowing the other and allows for clearer comparisons. So we will add y-axis 2 to the chart for this reason. So y-axis 1 will still represent quote count, while y-axis 2 will display the quote spread values. So if you change y-axis to y-axis 2, perfect. So just to go over what we've done. So the x-axis remains set to minutes because we want the time to be consistent across both layers. And y-axis adjustments, what we've done for the quote count, we've kept it as y-axis 1, which is the one on the left-hand side. And for the quote spread, we've chosen y-axis 2 to ensure the two data sets don't interfere with each other visually. Now, of course, the colors are the same, and we don't want this. So we can just change the colors in the color section. And I think, Megan, you have the correct colors.
Yeah.
Of course, if you have a color scheme, this obviously needs to be in sync with that. So now if you go back onto layer 2, we need to change the y-axis data column to quote spread. And that's exactly what we want to show. So now for tab 2, the trade volume tab, we want another chart GL. And what we could do, we can just copy and paste it, but we're not going to do that. We're just going to build it again. And for this chart GL, I want to show the trade volume, of course. So Megan, if you select a data source, chart size data source, execute and apply. And we just want one data layer here. So it's just simple x-axis 1, y-axis 1, and we still want it against minutes on the x-axis. But instead, for y-axis data, we want the size column. And we can change this layer to a bar. And another thing, of course, we need to change the layer name to trade volume. Perfect. And of course, change the color so it corresponds with the other chart GL in tab 1. And there we have our chart GL widgets.
Perfect. Is that you, Jemima? Yeah.
Yes.
Perfect. So next, underneath the pivot grid, we're going to add an accordion. So an accordion is a panel with expandable sections. Each section can hold a single component, including a nested accordion, or a workspace like a layout panel. These are great for optimizing space on your dashboard, as they can toggle the visibility of certain charts. So we'll change this to be horizontal, and we'll add a second section, and we'll expand that second section. So here we're going to add two more charts. In the first section of the accordion, we're going to have a tree map. I thought I saw it there. Tree maps are useful for visualizing large amounts of data in a compact space. For example, financial data, such as market share of different companies. Again, we will link this to our code statistics data source. And then we will also link the focus to be our pivot node, because that's what links all our components together. We want the tree map labels to reflect the selected breakdown column. So to do this, we're going to change the data. So here we're going to change the column to be breakdown ID. And then we want the tree map labels to, each node, we want the color and the size of the nodes so to reflect the code count. So we're going to change them to code count. And instead of having a fixed color as the default, we're going to change the color palette to be gradient. So here you can see, based on the code count, the colors go from light to dark. And then also the size of the nodes increase and decrease depending on the value of the code count. And then I'm going to pass this back to Jemima because she's going to add the next component.
Yes, a pie chart. So if you could drag and drop a pie chart. So why a pie chart? Pie charts are great for showing proportions and distributions within a data set. So they help us quickly identify which categories contribute the most to a total. So as we've done with all the other widgets, let's name this. So let's choose a name that reflects the purpose of the chart, such as quote breakdown. And now Megan will connect the pie chart to the correct data source, which I think is quote statistics. Okay, nice. So as Megan explained about the pivot node, what is the pivot node and why is it important for this pie chart? So the pivot node is a view state shared across multiple widgets in the dashboard, as we know. This means whenever another widget updates pivot node, the view state, the pie chart will automatically reflect those changes. So this dynamic connection ensures the pie chart is always in sync with selections or interactions in other parts of the dashboard. So in focus, as Megan's done, we want to add the pivot node view state. And now, of course, we want this to be in sync with the color scheme, which Megan has. It will be in style.
Oh.
Nice. And now we need to add the series key. So if you open the data section, instead of sim, just like the tree map, we want this to be breakdown ID. And well, basically the pie chart breaks the data down very similarly to how the tree map does, but it's just a different view of it. It's good to have as many charts as possible.
Yeah. So I think that's our completed chart. If we test this out now, you can see that once we break down by symbol, it breaks down all the charts break down together, and then that reflects the selected breakdown column. Next, if we go down by R, then it'll show you then the quote count for the most source, the highest quote count for each source, which if you see here, if we hover over for this one, it's 44. The lowest is probably 6. And then you can see it matches up with our pie charts as well. We have tooltips here. So if we flick over to trade as well, and we can go back to the start and break this down again. So I think that's it for the demo. If you'd like to learn more about KX dashboards, I've recently just released a course on our KX Academy. And it shows you everything you need to know about creating, querying, visualizing your data. It goes into depth about streaming and how to create different charts. So it covers topics such as an in-depth introduction to streaming, creating design components such as maps and multi-layer charts, some advanced querying, including update queries and virtual queries. It includes some simple user authentication on how to export your dashboards. This course is completely for beginners who have no prior experience with KDB or Q, because I provide all my code in the tutorials. So that concludes the live stream. I want to thank everyone for joining, and I want to thank Jemima for joining this with me. If you have any questions about the course or about this demonstration, make sure to pop us a message on Slack, or you can connect with us on LinkedIn. So thank you so much, everyone.